Hey there. I just realized I'm doing the aggregation thing and I'm not recording myself doing it. Let me just take this away for a minute. Here's the complex math object. I'm going to put that back to the pointer. I was saying, as I was saying at the end of the last video, which I've actually uploaded, but nobody's seen the one before yet. Now, you can see where this is going, but I'll just leave this out for a minute. Get rid of this. Just going back a few steps. Okay, so to make a complex math out of a real math, right? If I had one, what I've done is I've simplified some of these things by noticing that I don't need to make up a function for subtracting, for instance, because I can negate this. I did the same in IRealMath. Maybe it's a better example. Oh no, I didn't. Okay. I should. But anyway, in here what I've done is I figure out how to do the negative of a real number. That's quite easy. I take the real math and negate the real part, and then negate the imaginary part, and just return. These are already pointers, ready to be used. I add the real parts together, stored here, imaginary parts stored here, and to subtract, I do the negative. I negate b, the thing I'm subtracting, which is stored into these variables, and then I can use them. The evaluation direction is from left to right for and. That's part of the spec, I believe. I'm certain. I know that's part of the spec. It has to be. It can't go from this way to here because every piece of code ever written would just suddenly stop working. So I don't know if that was meant to be part of the standard, but if it wasn't meant to be, it is now. So therefore, this here amounts to a, what do they call that? Like a sequence point. I even looked it all up once and did a video on it. Okay, so by the time add comes along, these will have been resolved, so I can use them, and this is passing in by, well, that's by reference. That's no good. These have to be copies. I have to make a copy of these in order to not have them get trashed while I'm reading them in, right? If I'm reading these in, yeah, definitely. Maybe I shouldn't use references. Anyway, it's easy enough to fix that. I think this will make a new copy, won't it? One way I know I can do it. Oh no, I can't. Not that way. Okay, I can make a copy of the pointer. I can use my own double, just for temps. Just to be sure. Okay, so that'll do it. These will be filled in with the values, and then this here, it's pretty much passing pointer to pointers, but it's not these pointers, so I'm safe. So I have to fix another one down here. So negate, then add. Might as well initialize. So that's just, you should get into that habit, even if it's not going to be used, and even if the initial values are unused. Now here I've made a copy. This is the inverse for a real number. No, complex. To get the inverse, I'm going to do division by, instead of what I had before, I'm going to compute the inverse, which is a lot easier. The inverse of a complex number, Ri, real and imaginary, is first, it has to be, the thing is always divided by what they call the modulus or something. It's like in complex math, the radius from the origin of the complex plane to the number, whatever the number is, squared. So, Pythagoras thing. Real part squared plus real part squared. Oh, I don't want to use that. I can, but I don't want to use it. I want to use mole. Okay, that's okay. R divisor. Well, I call this 10. This is RD. R, D, right? D1, D2. Just like above. Wait. No. Well, I have a mole down here, see? But I think it doesn't use any. I could, but it's okay. Okay. And subtract. Oh no, subtract. Add D1, D2, and another one, D3. Let's say divisor. Get rid of this line and call this, well, I could call it D divisor. Then I don't have to change anything. divisor. That's the thing that we need to divide both the real part and the imaginary part by. No, I'm not actually not finished here. Oh no, that's correct. Then you take the real part, yeah, now we need to add these. I'm not done. Oh no, I don't. They are added, right? Because this is the real part, and this is the imaginary part, and the actual adding was done in this step. No, it wasn't, but it is implicit in the fact that we work out the real part and the imaginary part of the answer. We don't need to add them together. So that takes an inverse. If you work it out, it's not that hard to work out. If you have a complex number, a plus bi, right? And that number is a. Try to make it readable. A squared plus b squared, right? So that's a plus bi. So the hypothesis is 1 over a plus bi is equal to this, right? So if that's true, then, or maybe it's minus here. Well, let's see. If I multiply these together, I get certainly a squared and certainly minus 6. So there's got to be a minus here. Do I have a minus? No. And so I have to add another n. And no, I don't have to put that here. I could put it into one of my attempts. And IRealMath nay. pIR. That should do it. If you cross multiply this, you get right. That's the right thing, right? Or just multiply this by a plus bi, and you get. It's like it is a difference of squares, and the second square is negative, right? So that's clearly a truth, and so I don't have to do that complicated thing for dividing numbers. I have the multiplication. Let's use standard formula. This is it. The multiplication is computed by real part of A times the real part of B, and the real part, the imaginary part of A times the imaginary part of B, and subtracting those two gives you the real part of the product, if I computed it right. So it's in the other example, real AB would have been AC minus BD, if I believe is correct. In the other example, this would have been B and D in my original example. And for the imaginary part, that's the cross terms real A imaginary B and real B imaginary A into D1, D2, and add those together, and that's the real part. To do division, I have to do that thing again. I don't know what would happen, but I don't want to take any chances, right? Because of the reference thing. If it is supposed to be a const reference, I think you have to maybe say that they're volatile or something to make sure that that the compiler doesn't make a poor optimization and wipe out these values. But we don't have to rely on luck. This is going to work for sure, except let's put address here. Alright. So I'm taking the inverse of B, the multiplicative inverse, and then I'm multiplying that with A. And I have this multiplied. Alright. Now this didn't use pRealMath anywhere, but in fact it does, because this here, right, it uses it. Now let me just make sure I haven't made that same mistake elsewhere. No. It's safe to use those, so they're constant. I shouldn't be passing star of anything in. There shouldn't be any stars. Let's see. Other than in the declarations. Okay. Alright. Now, as far as the aggregating goes, here in the create device, what I'm doing is creating a RealMath, right, using the device create, and from this type, I get that will pull up the correct interface, and then I'm passing that interface into my IComplexMath, which then implements all of the IComplexMath implementations. For the aggregating, what we do is, instead of just using pRealMath directly, is I use my special thing here. The delegate thing. This sets up a template thing that I can use. I can make a class or struct. Struct. Do I need to know? Is that important? I don't think it matters, but I'll say class. Yeah, well, it doesn't matter. class, I'll call it IRealMath. Okay, and I'll let it contain the pointer to the IRealMath object, and I'll just call this mMath. Alright, real, sorry. So no p here, don't need it. Now that means that if this I haven't actually implemented them yet, but let's just go and change this constructor to say mMath, IRealMath equals, wrong side, the thing passed in. I could put it in its constructor. Maybe I should actually. And then to initialize that, I just say that's implemented. So that just makes this simpler. So I can put that here. Oops. I don't have to name it. And I don't have to have anything in the body of the constructor. Right, I'm just passing it down through to the member IRealMath. And now I just got to change all of these arrows to dots. It should work as long as I name this correctly. See, I've got all the functions like that. So now I just search for it. It should be the same as before, provided that my implementation of IRealMath it honestly implements the functions. So now I go to the IRealMath implementation, sorry, the interface file. There's IRealMath interface. Copy these and go and implement them all. The problem is I just have to name these. I'm getting pretty good at the naming. I don't know why I didn't pick that up. Oh, it's still got the. It still thinks it's the bool of the form it was before. I don't know why it hasn't seemed to flex right out. Anyway, that's okay. Pretty much that's all I gotta do over and over again. I could turn this into a macro. No, but this is the explicit. Here. All the way up to here. This doesn't have it anyway. IntelliSense is an unintellisensible. There. So I've implemented all the functions I need to implement. So it should compile. Oh, one more thing. It has to be a delegate thing. And then I want to use the other macro to implement it. Implement pUnkOuter. To implement the pUnkOuter into function. Oh dear. Doesn't look good, but we'll figure it out. Outer class, my complex math. Type of the type for the variable is IRealMath. And the variable's name is IRealMath. It's supposed to, if it works, it should give me my pUnkOuter. Otherwise, everything should be the same. Of course not. Oh, sorry. Doesn't make any difference to the outside world. This has to be a class as well, I think. We should have two of these. One for class and one for struct. Followed by a bool. Did you forget a semicolon? No. Maybe. Return. I probably did forget a semicolon, but I don't see it. Add sub, or I've got too many curly. Return real life at close bracket, semicolon. I just removed a bracket, maybe that was missing. Or oh yeah, I had an extra bracket. Dib. That is true. Okay, now you see this thing here, this RealMath. The address of this RealMath, oh, I'm doing it in the outer class. The outer class is destructor, it's deleting wrong. I'll do it in, let's just, I don't even have to declare this one. That's supposed to go. This is an object, not a pointer. RealMath destructor delete this thing. Now, you don't have to. No reference counting is required in this class. The reference counting mechanism is implemented already for this other class. Make access private. No problem. See, the outer class, the pUnkOuter, derives from the device thing, the reference counting thing, so therefore, when this outer thing is copied, this inner part doesn't get copied because only reference counts go up and down. Assembly access specifiers. What assembly? Oh, public friend, sorry. Any members in here don't need to count references, right? Div true enough. That's already being done. So that means that there will only ever be one RealMath, no matter how many references to this object there are. There will only ever be one reference to this object. I'm not copying, I'm not reference counting it. I don't have to. I don't have to do that for any malloc pointer or nude or whatever. Although this is wrong. Sorry. This is wrong. This should not say that. It should say this. It's turning into com. I can't believe it. I have to say that because it's not the right. That's in another DLL, right? I'm not allowed to delete it. I wish I could somehow force the compiler to tell me that I can't. Well, it should have. It should have said can't. Maybe it did. I'll look at it later. Right. Now, I'm going to pause this video and I'll continue on in a minute because I've got to go to the little boy's room.